Think now you're able to hear me. Hi everyone, welcome back today to my final stream. This is the final stream of I'm sorry, of the Global Hack Week. Sorry, I just woke up. But we're ready. Ah, how are you doing? How's been your Global Hack Week? Hi Sumi, hi Sonny, hi Tintin, hi Will David, hi Will, welcome back again. Uh, blah, 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 blah. Yeah, let me share the check in this link. I forget to add it to Discord, and let me also share it with you on Discord. Um, so were you on the Yale Jesser mini event? Almost got some. Oh, some parts were near of us, and yeah, I think yeah. Now you're able to see that. It let me also update the message. Um, don't forget. Don't forget to register in the here and updated. Okay, cool. And okay, yeah. Hi Charlie Bear. Hi Tamara. And yeah. So yeah, just we were playing some hours ago Joe Jesser, and we playing Joe Jesser and Joe Static, which is an alternative for Joe Jesser. Okay, so today we're going to jump into just a quick introduction into Solidity and the Remix IDE. So let me share the link with you. Here's the IDE that we're going to use, and um, we're going also gonna use the documentation of the Solidity. So let me share my screen again. Let me go here, share the screen, and here share. Hmm. I think now you're able to see it. Cool. So if you don't know Solidity or if you don't know anything about smart contracts, basically Solidity is a language for creating smart contracts in a blockchain, in the Ethereum blockchain. So yeah, you have a lot of cool things for making Solidity. So Solidity is really heavy based on C and C++. It has hard typing. So the cool thing about this is that we have like if you were watching the streams that we were making on the week, um, we also saw Viper, and we also take a little look to Smart Pi, which are some other languages for creating smart contracts. And yeah, so I think this should be now the difference for creating smart contracts. I can assume that we're going to have a definition of the contract, some tests to run the contract, and then we're going to deploy it into our blockchain, right? So okay, so ideas for improving solidity of this community, blah blah blah. So getting started. Okay, so understand smart contract basics. So if you're a new concept of smart contracts, we recommend you to get started digging into the introduction of smart contracts section, which covers the following: a simple smart contracts, blockchain basics, and the Ethereum virtual machine. So let me know if you want me to just take a little bit of a quick look into this documentation if you want to know a little bit more about the smart contracts, blockchains, or the Ethereum. If not, we can just continue. Okay, so once you are blah 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 blah, so install Solidity compiler. So there are various ways to install Solidity compiler. So we're not going to use that. We're going to use today the Remix IDE, so we can continue with this. Then learn more in translations. Okay. Contents, introduction to smart contracts, blockchain basics, Ethereum virtual machine. Okay, so literally by example. So voting. So the following contract is quite complex but showcases a lot of Solidity features. It implements the voting contract. Of course, the main problems of electronic voting is how to assign voting rights to the correct person. Yeah, we were also making that a smart contract about this. We were trying to make a smart contract that can handles the voting of I don't know, a poll or a votation in a political way or anything like that. So yeah, we'll solve problems, but at least we showed how to delegate voting can be done. So that voting counting is automatic and completely transparent at the same time. So the idea is to create a contract per ballot, providing a short name for each opinion, and then creator of the contract who serves as a chairperson will give the right vote to each other's individually. Okay, so the person behind the addresses can then choose to either vote themselves or delegate their vote to a person they trust. At the end of the voting winning proposal, we return the proposal with the largest number of votes. Okay, so we have first pragma solidity here. So we are looking up at the title here. Okay, so we have our first contract, which is just contract ballot. So this declares a new complex type, which will be used for variables later. It will represent a single voter. So struct voter, unit weight, voted, delegate, vote, then a struct proposal and address public chairperson, mapping address, voter, public voters, proposal, public proposals, right? And then we have a constructor which is proposal's name. Okay, so you create a new ballot to choose one of the proposal names. We have a chairperson, which is the message that sender, the address of the person who is sending that message. And I think we declare that here. Yeah, chairperson. Okay, so voters is equal to chairperson of weight is equal to one. And then for each of the provided proposal names, create a new proposal object and add it to the end of the array. So we start a new for, we traverse the array, so creates a temporary proposal object and proposals push, appends it at the end of proposals. So give voter the right vote on this ballot may only be called by chairperson. So function give right vote address voted external if the first argument of require evaluates to false execution terminates on all changes to the state and to error balances are reverted. This is used to consume all gas in old EVM versions, but not anymore. Um, it is often a good idea to use required to check if functions are called correctly. So as a second argument, you can also provide explanation about what they went wrong. Okay, so message sender is equal to chairperson, so only chairperson can be the right to vote. Okay, yeah. So requires are just like making tests before uh, uploading our contract, right? So voters voted, voters already voted, blah blah blah. So then delegate your vote to the voter to function delegate address to external, then voter start send. Okay, yeah, cool. So this example seems cool. I think it's kind of a big deal for as a first example. So let me search a quick example here in ChatGPT. So let me ask, create a simple contract in Solidity that I can use to learn Solidity. So let me share my tab here. So certainly here's the Solidity smart contract that represents basic store mechanism. This contract allows users to store a number and retrieve it. This is a commons beginner contract because it shows you the basic structure and operation of a Solidity contract. Okay, so contract simple storage, you in 250 private number, event, okay. Yeah, so let me copy and paste this into a new file in the Remix IDE. So let's open contracts. Okay, so I think this is the same example. Number, yeah, it is the same example actually. Okay, yeah. So let's look at this example here in Remix. Let me see if I can zoom this out. And cool. Okay, so first we have pragma solidity, the title of our contract. We have storage. Then we have variable custom. Okay, so first we start a new contract called storage. This is going to have a integer of 22. I mean, 256 bits. And then we have a store, it's a variable, then parameters and value to store. And then we have a function called uint called store, which is going to receive a parameter of a number, and it's going to be a public function. And then the return value of this number, right? Okay, cool. So I think this is a cool example for this. Hi Indigo, welcome today. How are you? So can we make the project Yu-Gi-Oh with them? Okay, okay. Yeah. I think it's real chaotic for just the first example. So we're trying to make the first introduction. So let me ask ChatGPT, which are the data types that Solidity can use in their contracts? So I think this will help us to understand a little bit more um, which kind of data types we can use in Solidity. Because if you're first or if you have never used something like C or anything like that, maybe this seems kind of rare for you. Okay, so let me share again my ChatGPT here. So okay, so we have value types, we have booleans. The possible values are true and false. Integers, we have int or int 256 signed integers, then unsigned integers. Then there are also smaller variants like in int a, u in and so on. So also we have addresses. So address is a 20-byte value, size of an Ethereum address, and address payable, similar to address, but includes additional members of sending ether. Okay, so this is basically whenever we want to know like the identifier for some address or for some person, we can use that address to know like who is making this call or who is sending this message in from where, right? So we use that address to know like the address of that person in the blockchain. Okay, so then we have also a fixed size byte array. So we have bytes 1, 2, and until 32. And we have enums, so used to create user identifier types with a finite number of values, then fixed point numbers, not frequently used due to the lack of support. Okay. And also we have dynamic bytes arrays. So we have arrays, dynamic arrays. We also have structs, which basically are like objects, mappings, that associate containers that pair together keys with values. Okay, so you can imagine this like a dictionary in Python or like a map in C or yeah. And also we have contracts, which a contract is used as a type, but you can also create a new instance of a contract to make calls to the contract. Also, we have functions and modifiers. And here's a quick example of the booleans, signed integers and signed integers, the address of somewhere of someone, enums. Okay. Also, we have references of arrays. We also have a struct like is somewhere something like an object, and a person, which is a class, and then we have the map and also the type of contract. And yeah, cool. Okay, so now we already have take a look into that. So let me see. Companion channel validation types. Okay, so we already see the types. Okay, so operators is important to know. So we have the same operators as JavaScript or Python. So we have not, and, or, equals, not equals. Okay, so we have also integers, the comparison values, which is lower or equal, lower, equal, not equal, greater or equal, greater. And yeah, okay, so we have modulo, we have uh, the same arithmetic operators, plus, minus, times, divided by, modulo, exponentiation. Okay, cool. So comparison, bits operators. So we have shifts also for making bit operations. Exponentiation, fixed number point, address. Okay, yeah. So the address type comes in two largely identical flavors. So the first one is like the one I said, it's just an address, and the other one uses member of transfer and send, so we can make kind of transactions with that. So the idea behind this distinction is that the address payable is an address you can send either to, while you're not supposed to send either to a plain address, for example, because it might be smart contract will not be accept either. Okay, cool. And we have all members of addresses. So for a quick reference, okay, so I think this is more than enough for introduction to the data types that we have in Solidity. So what do you think if we take a look into other examples that we have here? So we already saw the contract of the storage for storing a number. Also, we have other example that says owner. So we have title owner. We start a new contract where we have address, a private address of the owner of something. Then we have an event called our owner set, which takes an address and takes two arguments, an old owner and a new owner. Both of them are addresses that are indexed. And then also we have a modifier. So what is a modifier and what is an event? Let me search that. So what are modifiers and events? Okay, so in Solidity, both of the modifiers and events are distinct roles as powerful tools in development of smart contracts. Let's break each one down. So modifiers. Modifiers are a feature in Solidity used to change the behavior of functions in declarative way. They can be used easily change the behavior of functions or to check preconditions before the function is executed. For example, a common use of modifiers is to check if the function caller is the owner of the contract or if certain conditions are met before the functions proceed. So we have contract ownable, which is a public owner. Constructor owner is equal to message.sender. Only owner require. Okay, so we have again some modifiers and change the behavior functions delivered away, so they can be used easily to change the behavior function or to check the conditions before functions. Check if the function caller is the owner of the contract or if the certain conditions are met before the function proceeds. So okay, so it's the same example that we had. So we have owner is equal to this, modifier only. So this underscore is where the function body will be inserted. Okay. So we have only owners, which is first we kind of assert that the message is equal to the owner. And if not, the color is not, we're going to return a message called the color is not the owner. And then we have function set new or owner, which is same function, right? So the only owner modifier checks if the caller is the owner of the contract, and any function that has only owner modifier, like set new owner, will have to check if the only owner modifier is executed before its body. Okay, got it. Okay. So we're saying something like, hey, initialize a new function called set owner who is going to receive an address and is going to receive a private variable, which is new owner, and also try to use the public modifier, which is called only owner, before doing that, before executing that. Okay, yeah. So it's like an assertive function that helps us to assert something, I think. Yeah, but let's try to look up into the documentation here. Let me see if we have modifiers. Mm, Solidity modifier. There you go. Function modifiers. Yeah. Oh, I love this page. Also, Viper had the same kind of page for this. It was called Viper by example, and this is called Solidity by example. So function modifier. Modifiers are code that can be run before and or after a function call. So modifiers can be used to restrict address access, validate inputs, and guard against reentrancy hack. Okay, so we have the same thing, is the same example that we had here. So we'll use the variables to demonstrate how to use modifiers. So address public owner, public X, and public locked. And then we set this transaction to the messenger. So modifier to check that the color is owner to the contract. Okay, so underscore is a special character. Um, where are we using underscore? Yeah, here. So underscore is a special character only used inside a function modifier, and it tells Solidity to execute the rest of the code. So modifiers can take inputs. This modifier checks if that address pass is not the zero address. So we do the same thing. We require the address, and if the address is not equal to zero, it's not a valid address. And we do that. We try to call that validators. We check the first validator, the first modifier is only owner. So first, before executing or change owner, we are going to execute that first modifier, which is only owner, and then valid address. And we are going to pass the same private variable that we were using. Okay, so we're going to say execute only owner and execute valid address. And if both of them are good, then you can continue and set the new owner. Well, the owner is going to be equal to the new owner, right? And then we are going to use modifiers again to so modifiers can be called before and or after a function. So this modifier prevents a function from being called while it is still executing. So require is not locked, no recurrency, and then decrement. Okay, cool, 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 awesome. So let's continue with the example that we had here. So we had this owner, and then the event that we were did not checked. So, okay, let's see. We have Solidity by example. First, variables, error, if else, mapping, array, structs, data allocation function, events. So, events allow logging to the Ethereum blockchain. Some use cases for events are listening for events and updating user interface or a chip from storage. So, we have the event declaration. Up to three parameters can be indexed. Okay, so this is something. Okay, so this is like Viper. So indexed parameters helps you to filter the logs by indexed parameter. And we have event log, address in sender, string, and then test public, hello world, hello VM in another log. Okay, cool. Yeah, so now that we understood events and we understood um, modifiers, let's continue with the example that we had here. So we have our let me. So Will David said something. So what about simple faucet contract made with ChatGPT? We can deploy it and verify it in either scan to interact with it. It will be fun, I guess. Okay, so let me search for that. So let me copy. Let me go into the Twitch chat so I can. Oh, well, let me just write it. So let's ask ChatGPT to do that. So can you please create a simple faucet? Faucet what? A simple faucet contract that I can deploy. Of course, below the simple Ethereum facet contract, so this contract will allow the owner the address deploys it, so to deposit Ether into the contract, and user who can request Ether for the faucet. So we have public owner, drip amount, Ether, the amount of Ether that's sent to users in each transaction, and event signal with Ether is sent. So event send, address, index beneficiaries, modifier only owner, function to change the drip amount, faucet function. So require not enough error in faucet, payable, message sender, then transfer. Okay, so let me copy and paste this right here. So the new file, and this should be for faucet. That's all. Pasted, blah, 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 blah. Okay. And let me close this and okay. So we have address owner, drip amount, etc. So the event signal, whether dancing, blah, 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 constructor, function set rip amount, then function request error, payable, order, then transfer, then address, cool. So let's see. So before continuing with this, we didn't even went into creating our first app or Hello World, but I will take that for the second hour of the stream. So Pragma specifies the compiler version of Solidity, okay, and the contract Hello World is going to be a single string called Hello World. And then let's go to our first application. So here's a simple contract that you can get, increment and decrement that can store in this contract. So we start a contract counter and then we call the function. Okay, so we have our integer public count function to get the current count, then a function to increment by one, then decrement by one. Okay, so my question here is how can I deploy this to the, or how can I play it? Let me add another file here so I can put the hello world. So 5 hello world, that's all. And then let me copy and paste this code that I had here. And okay, so I'm going to say 0. So we have created hello world and we just close this and compile it. Compile hello world, compile and run the script. So set a custom that run script now. Okay, so let me ask now, how can I compile and run a contract in Remix? So compiling and running a contract in Remix is a straightforward process. Remix is an open to blah blah blah. Okay, so running placing contracts. So left side panel, you should find blah blah blah. Sold extension, my contract got sold, paste the Solidity contract editor. Okay, for example, check the compile button. If there are any errors in the contract, they will display contract. So we have so after successful completion, deployed run transaction for the icon, the left-hand panel. In the environment dropdown, select the appropriate environment, JavaScript and handshake the web provider, and then interacting with the contract. Okay, cool. So let's just continue with this. So then accessing contract details under the deploy contract section, you can view details of the contract by clicking on the small down arrow beside the contract name and then view contract address, ABE, and other details. Okay. So deploying the contract. Okay, so but I want to know like how can I run that? Like I wanted to run and compile this, but it says you don't have a script to run. Set it with add custom.b, run the script, not a specific tag. So I say I receive this message. Let me know what this means. So some custom blah 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 blah. So the custom tag within specs suggests that you're using some custom tools, system expected blah blah. Okay. Okay. So we have compiled hello world, so it is already compiled. And then plugin info, and then whatever. What else? What else? Yeah, I want to compile hello world. So okay, yeah. So it says choose the script to execute right after compilation, but adding the okay, got it. So I need to put the title, the dep, and the custom dep. Okay, yeah, cool. So this is necessary, I think, for running the script. And the comments are something like C++. So we have here, we should add a title. And I'm not passing you. I'm not sharing my screen. Yeah, now I think you're able to see it. So we have add title is contract name hello world, and we have add dep um, simple hello world, and then finally add custom the dep run a script. And let me see the other examples so I can see the path. So data scripts deploy with errors.ts. So are they all the same? Set and change owner and then valid. Dep implements body. Yeah, so I'm going to assume that this is the one. So scripts deploy with error with bird tree. Okay, got it. Scripts deploy with error. .ts, and let me recompile this again. So it is already compiles. So compile run scripts. So you have no scriptify. Mm, set it with that custom dep run script. Didn't I just do that? Mm, I even copy and paste this. So again into hello world, and then go here, here. Let's try to let's try to run this again. You have not set the script. Oh, I don't know what I'm doing. Okay, so let's try to run the storage then. Compile and run. And this actually runs it. Okay. So type library name C variable commands running deploy headers. Okay, so I can assume that we are running this already. So now the question is, how can I stop this? Um, oh yeah. Hmm, interesting. So you don't need to, in order to deploy the contract, you only need to go to the Fort icon and select where you want to deploy it. So you mean the Fort icon is this one? Like publish an IPFC, IPFS, or something like that? Deploying the storage address, Okay, so it actually is running and it was deployed to headers with no deploy with headers. And let's see. So import deploy from headers, sync cons away deploys, and blah, 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 catch console log, blah, blah. So this script can be used to deploy to the storage contract, use header JS library. Please make sure to compile run to file before running this script, and then use the right click to run from the context menu. Okay, got it. So let's try to run this here. So deploy it with headers. No, what's here? So publish on Swarm. So you mean this ones, David? No, more left. Oh yeah, here. Deploy and run transactions. Got it. Mm-hmm. Okay, so we have environment remix, account, the gas limit, contract, storage, that's all. Please make sure the current network is compatible with the AVM version parties, otherwise, So then deploy it. Okay, so it is deploying storage, so creation of storage pendings, and then the VM is already making this. So we have true transaction mine and executes successfully, then block number, block hash, contract address from to. Okay, cool. So we already deployed it. Okay, so true transaction mine and execute so block hash, block number from to storage, then gas. So now how can I test my contract? Is my question right here. Let me quit this. Let me quit this again. So we're in storage, that's all. And let me see how can I test. So constants, immutable, reading and writing state variable, editor and weight, gas for array structs, function view, advancing inherits, payable, sending, transfer interface visibility, the decal function selector, try catch import library, API encode, verifying signature, applications, write and slot, hacks, reentrancy, test, yeah, test. So we have a cheat now. So examples of fussing with a cheat now save solidity contracts as so in the folder where your contract is stored, execute the following command. Secure toolbox inside Docker, you can will have code a cheatnet test commands. Okay, so a cheatnet test sol contract text counter, and the test counter is here. Test counter is counted, so a cheatnet test true, public view returns a half false count. Test assert the unit, external, more complex example. Okay, I'm not sure if testing is what I wanted true, but so after you're compiled, you go to for no, so we can interact with the contract in the for icon too. Okay, so we can go just here in the for icon and then start something. Transaction recall, deploy contracts. Okay, got it. So this is like the entry point here. So let me store something. One. Oh, okay, so we did interact with our contract. Let me see the terminal. So can I export two? Then we have a call here. So we have another input. And we have six. Can I store it? Yes, I can. Did I store it? Yeah, I stored. Oh, okay, yeah. Okay, thank you so much. Thank you so much, Will. Yeah. And this is a little bit easier than the Smart Pie version. Okay, got it. So let me see if I can run and test this. Let me compile this, compile it, and then can I deploy this? Yes, it is deployed. Then let me see my deploy contracts. So I have hello world and then greet. Awesome. Okay, got it, got it. Okay, so for each kind of entry point that I declare, I'm able to interact with that, right? So I have function store. Okay, so retrieve and then hello world. So I have just a string public grid. Okay, and then in storage, the only one that I have is the store function retrieve returns the number. Okay, got it. Got it, got it. Cool. And let's try to see if we can run the external faucet that we had here. Okay, so let me try to compile this and see if there's a problem. Okay, so there's no problem. So let me try to deploy this. So then deploy it. So was it? Yeah, it was deployed. So we have deposit, request either, so withdraw, drip amount. So I have my drip amount of this, then get balance, then owner. So this is my address that I declared, like was declared here. Then deposit. And if I want to deposit, can I do something with this? Block hash transaction. So transaction might executed success from to gas. And okay, so request error. So transaction is not enough error in faucet, and then withdraw. Okay, so withdraw is what? So withdraw transact not payable. Okay, and it returns again my drip amount. Cool. So we can interact with this. So is there okay, so yeah, we deploy blah, blah, blah. Yeah, thank you so much, Will. Thank you, thank you, thank you. Okay, so then let's see if we can interact in some other way with this. Um, Let me just search for something. Blah, 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 blah. Just give me a minute. Okay. Blah, 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 blah. Just give me a minute. Blah, 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 blah. Okay. So, what do you think we can do? Okay, so I know that the mascot of this year is a hypo. So, can we interact in some way with hypos and hackers here? Huh. So, let's see one of the examples that this page has so we can interact with it. So, we have apps, we have Ether wallet, multi wallet, the high interval mapping, glasses token, simple bytecode contract, upgradable proxy, deploy any contract. Hmm. First app, variables, constants. I think we have an example of the ballot that we had here. Yeah, this one. This one, I think this is interesting to understand. So we have title ballot that implements voting process along with the vote delegation. Then we have weights accumulated by delegation if true. That person already voted and person delegated to then vote. Proposal if you can limit the lead of a certain number of bytes. Um, okay, so always use one of the bytes. Much cheaper. Yeah, so voting public chairperson, then so they create a new ballot to choose one of the proposal names. So then we have another constructor called proposal names. So it's the chairperson, the voters, so the chairperson is equal to one, and then proposal. Okay, so let's try to compile and run this. So let me compile it and then go here and try to deploy the ballots. So proposal names, let's see, will be wheel, um, indigo, sunny, and David, Kingsley, and which other one? David. Deploy this. Was it deployed? Creation of valid error. They are cutting expected array, value argument value, and will. Oh, so it assumed that this is a string. Okay. So we have Indigo, Sunny, and Kingsley, and David, and there you go. So let me deploy this. Invalid entry value, argument value, value will, encoded valid argument. What? So valid contract, public, address. I don't know this. Okay. So we're cutting value, blah, 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 argument value. Value is equal to will, code, invalid argument. Okay, so let me see the code again so I can understand. Mhm. Where's value? Value, value, blah. Where are you? Where are you? Ballot, voter, wait, name, vote count, I have proposal, public proposals. And a proposal is this, so it's the name, and then, oh, okay, so we expect to have things, the unit, or just, or the proposal just one? So proposal name, so proposals, so constructor, mm-hmm. Delegate, sender, proposals, uh, so by name in the bold count, and then do we have something more to do? Some other proposal names, chairperson number. So proposal is just a public. Okay, so create a category called proposals. Let me search for proposals. So they create a new bar of shows proposal names, proposal names, names of proposals. Okay. So let me go here again and instead pass just number, David. Expected array, David could invalid. So I need to pass David. Current value, argument value, value David, version bytes. Invalid RFI value. So we have call data. The arguments, parameters, proposal names. Where is proposal name? Proposal names. Proposal names. Where are you initialized? Okay, so we have parent proposal names is name of proposals. So constructor memory proposal names, and here we have chair person is equal to message sender. Mm, okay. So we have just three persons of this. Maybe it doesn't take Alice and a single string. Yeah, that's what I'm trying to look up. So create a new val of chosen one and have proposal names, find proposal names of proposals. So bytes 32 memory proposal names. Okay, so chart person, messages that sender, then voters, then proposal names that land, then proposal names. So does it take just memory proposal names? The thing here that I don't understand is where is proposal names from or where does it appear? So I think it's just an array here, but let me see the parameters. Encode it. Um, byte 32 estimated creation cost infinite gas. Byte 32. Internal proposal names. It says that it is an array, right? Question value the encoded arguments. David invalid argument. So is it expecting a tuple? Or should I pass the name and the vote count? So the construction is taking a right time, so I think the pass will work. Okay. Let me go into the stream chat again. Let me go now to my stream and let me copy and paste the wheel message. Okay, and then let me paste it here. Ah, interesting. Hmm. So what can we do with this? Okay, let me pass this to ChatGPT. Mhm. Here we go. So when I want to interact and deploy this new contract, it asks me, does I need to pass an array of strings for this, for deploying it? You can deploy run transaction section, choose the right environment, Under the context, select ballot, you see a field to input the constructor parameters, so since the ballot constructor requires an array to you need to convert the string proposal to byte to tuple. Oh, okay. Proposal. Oh, got it. Okay. Okay, so let me share my tab again. Let me go here, and instead of passing this, let me pass it to bytes one byte I have here. So let me copy and paste this, and then this maybe coding arguments error incorrect data lane no blah 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 blah. What incorrect data land? No. Balance of Illustrator to click deploy. Okay, so let me copy and paste again. Hmm. Bytes 32. Bytes 32. String to bytes 32. Yeah, this is what I'm looking for. Online string bytes. So for proposal and this, and then go again here. Paste this. Expected array value. Argument blah blah blah. What? Okay. This. Incorrect data lane. Well, why is this incorrect? Ah, Yeah, maybe it's without the zero x. No. Huh. Okay, so what does incorrect data length mean? In the context of streaming solidity, incorrect data length usually refers to the issue where the data providing a function constructor does not match with the expected length. Array length is matched. If a function constructor expresses an array of central length, then you provide an array of different length. You may consider this function set data units 5. Oh, okay. Okay, so I need to pass for minimum some a minimum par of array. Border, blah, blah, blah. Okay, let me see the code. Self-delegation is disallowed. I delegate a ham. They give a both param from winning proposal. Okay, so I have my proposal, then chairperson, memory bytes 32. Set data, font set data, set proposals, giving address, giving right to vote, delegate, vote, winning proposal, winner name. Well, I don't know then. Byte versus string when delegated by the type of a specific blah, 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 you can encounter data line issues if you're provided your actual data short or longer you can get session error. Fixed side arrays if a function expects a certain function blah 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 blah. I'm stuck here. Well, maybe. Let me open the zeros. And then go here and let's see. Yeah, I needed to open the zeros. Okay, yeah, let's go. We got it. Okay, so we have the contract address from to transaction code. We have the proposal names. Okay, got it. Let's go. We did it. So I'm going to take 5 minutes to go to take some water and wash my head a little bit, my face. So we'll be back in just 5 minutes. Okay, so I'm back again. Hi everyone. Yeah, I went also for a to take a little toast with jam. Have you already taken your meals, your breakfast, dinner? Mm, so I think that after the stream, I'm going to make some eggs with chorizo. Okay, so let's continue. So we already passed this, and we learned that we need to fill out the zeros for taking some options, right? Hmm. Hmm. So let's see. We already have made the deployment. So the thing is, can I interact with that? Yeah, I can. So I can see the third person. Okay. Okay. Got it. Okay, okay. Cool. So I know that some companies uses the this kind of smart contract for interacting with games. So would you want to, do you want to search a little bit for more of that of how the smart contracts are used in games? How are smart contracts used in games? Hmm. Okay, so role of smart contracts in gaming. hmm Security and transparency, ownership in game assets. Okay, yeah. So I think that they are like, will they use them in NFTs? Got it. Okay. Okay. Yeah. 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 So basically, they are used for making economies, decentralized economies, like the don't letting like the game developers to be the ones who are in the control of the economy in this case. Mm, okay, so we also use them in the metaverse. We have play along, planar models, in-game items, areas of application metaverse, protection of copyrighted works, managing ownership of virtual property, custody chain, code of conduct, and okay, yeah, so protection of copyrighted works, so the work of innovator, experts, and designer being impacted in the interest of intellectual property frauds as a result of litigation. Blockchain-based smart contracts employ non-fungible tokens, which are proof of ownership tokens in certain project. In metaverse gaming, we need mechanism to protect unique avatars and graphical designs that are earned during gameplay, which possesses monetary value. So smart contracts in metaverse gaming govern the ownership and transfer functions according to the norms of the game and ensure the entitlement records cannot be tampered. Okay, so how are NFT smart contracts made? Okay, so let's see. We have a post in LinkedIn. So we have the NFT smart contract. So smart contracts are created by minting process. Minting process is created by creating the NFT. During the process, the smart contract is stored and linked to the blockchain, mostly Ethereum. So the protocol used to link the smart contract to the Ethereum network is So there are the main benefits of smart contracts. Mentioned before. Okay. Okay, so we actually have here an example of Solidity. So we have first Open Zeppelin, uh, the encoding with no the protocol used to link the smart contract to the Ethereum network. Okay, so we're importing that protocol first. Okay, so we first import that protocol, then we also import counters. So emotional shapes is okay, so uses this protocol. So using counters for counters in counter, private token ID counter, then constructor emotional shapes. But your internal so your API string memory. Do we know? Okay, so function mint returns the token and then the token ID increments and then save mint. So NFT smart contracts are still their infancy, the future, blah blah blah. Yeah. Okay. So, okay, let's see the recommendation of Hedera, because Hedera is one of our um, sponsors. Let's see, we have something interesting here. So, NFTs and smart contracts are two of the most exciting blockchain technologies, still made of blah, 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 blah. So, as NFTs are digital assets, much like cryptocurrencies, and we can be owned by one person at the time. Unlike cryptocurrency tokens with millions of billions of the same token existing, NFTs are often limited to a supply of one unique digital token. So these assets are typically tied to a link that points to a file stored on IPFS, Interplanetary File System, and the asset unique token ID and metadata acts as proof of the ownership for the individual who buys the NFT. Okay, yeah, so explains NFT. So alternatively, one could design NFT series with Tamagotchi style pattern NFTs, then grow, carry, die, blah, blah, blah. So can NFT be physical goods? NFT themselves are always digital. Still, an NFT can be used to represent ownership or partial ownership of real-world objects. For example, a jeweler could use an NFT to sell partial ownership rights to precious diamonds. So the jeweler could store diamonds and mint unique NFTs representing partial ownerships and are fractionalized asset ownership. Other uses for NFTs. These digital assets have numerous real-world use cases, blah, 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 geolocation technology to let customers unlock unique NFTs when shopping at their stores. Additionally, these stores can reward people with NFTs when they buy a specific product, blah, 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 more NFTs, blah, blah, blah. So I just want to know, like, the link of the smart contracts with the NFTs. So let me search again. Okay, so then let's ask ChatGPT. How can I think that smart or like how smart contracts are related with NFTs and what are and how are they linked? Okay, so let me short my tab. So smart contracts and NFTs with being a specific respect. Let's break. Okay, so we know already what are smart contracts. So the player has so what are NFTs is non-fungible tokens. Yeah, we already saw that. Mhm. Okay, so token standards. NFTs are built using a specific token standards. The most common standard in Ethereum is ERC 721. So the standard ensures that the token has a certain properties and methods that make it non-fungible. There's also RC 1155, and more generalized token standards, blah blah metadata. So each NFT can have metadata associated with it, defining its attributes. This metadata, which might include description attributes, images, or even links to other media, is often stored off chain due to storage constraints of the blockchain. The link to this metadata is used stored within the NFT smart contract. Wrote this programmably, maintaining. So when NFT is created or minted, it's done through a function call or its corresponding contract. Platforms like OpenSea, Reliable, and other facilities process, but behind the scenes is the smart contract that is doing the work. When you buy, sell, or transfer an NFT, you're also interacting with a smart contract. In summary, okay, so can you make a quick example of this in Solidity? Yeah, to be honest, I'm not a fan of it, and I think NFTs are. I think they are not well. So I think we don't have like enough infrastructure for um, having the proper use of NFTs yet. Like we don't even have neither the regulations or like not all the countries have the same regulations like the US or so we don't have neither regulations or the infrastructure for continuing with the development of the correct development of NFTs. So give me just a minute here. Mm, okay, so let me see. So of course, below the simple NFT using Solidity, this example would follow the RC standard, which is the most common follow standard Ethereum platform. Okay, so we use the protocol, then we use ownable and counter. So simple NFT is using counter for counters in counter. Okay, so let me blah 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 blah. So can you explain me a little bit more the code you provided? Blah, 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 example imports. So the first import are I think are parts of the protocol. This is an extension for the standard RCT 721 token provided by Open Zeppelin library. The numerable part means you can list the token, all the tokens owned by that address. Oh, okay, interesting. So I can imagine it like if I pass an address, that enumerable is going to return to me all the current tokens that that address is owned has owned by or has owned. Uh-huh. Yeah, yeah, I understand Indigo. Like it's also a really. Have you ever saw the Office episode where Michael says that the plan is not a pyramid thief, the Office pyramid, a pyramid scheme. So yeah, let me copy the link with you. Yeah, so so a lot of times I imagine um the problem is with this.
Don't worry about Phil. He drives a Corvette. He is doing just fine. Okay. Calling cards.
So
The
this is the
more
scene where
investing, the more money we're all going to make. It's not a pyramid scheme. It's not even a scheme per se. It's
some like a lot of times I imagine like that scene. Yeah. Okay, yeah, so let's continue. So this extension of the standards RC 721 token provided by OpenSimply. The numeral part means you can list all the token by that address or counter. So this utility provides a simple way to increment and decrement counters. So we'll use to manage the unique token IDs. Then we have ownable.sol, which provides basic authorization control functions, simplifying the implementation of user permissions. Essentially, the account that deploys the contract becomes the owner, and certain functions can be restricted to only be callable by the owner. So also we have a contract definition. So contract simple NFT is ownable. Okay, so we're defining a contract called simple NFT that inherits from both enumerable and ownable. Using the counters library for counters and counters, that counter private. So we're indicating that we want to use the functions provided by the counters library for the counters that counter type. So also token ID counter is our counter that we help generate unique tokens. So we have a constructor that it says simple NFT is NFT. So this constructor of the contract, which is called once upon deployment, so initializes our contract with the name of simple NFT and symbol as NFT, and then we do the minting. So the mint function allows the user of the contract to create new tokens. So token counter that increment increases our token ID counter, ensuring each token has a unique ID. Also, it's a function for the ERC 1721 standard that safely mints a new token to the given recipient. So it also have, so we also have is our internal function to associate metadata with the newly minted token. Okay, so also we have managing metadata. Okay, so mapping private token metadata function. Okay, so it is a private mapping that links each token ID to its metadata string. Then it's an internal function that sets metadata for a token. It's marked virtual, which means that it can be overridden by derived contracts. And also token metadata is a public function that allows anyone to retrieve the metadata for a specific token ID. So the only owner modifier I see in the mint function is from the ownable contract. This ensures that only the owner of the contract, typically the account that deployed it, can call this function and mint new tokens. So that's a brief run. Okay, yeah. So let me copy and paste the code so we can see it in our IDE. So let me copy, then go to Remix again, start a new file. So let me create a new file here called contracts. There you go. So I don't want to see artifacts. I just want the contracts. So then it wants six NFT. That's all. And then let's close this, copy and paste this, and then do we have a problem? Identify what? No, we don't have anything. Okay, so we have it here. Okay, so we already saw that. Let me try to compile this. Okay, it was already compiled. Then let's try to deploy this. And was it deployed? Let's see. Yeah, it was deployed. So where are you? There you go. So we have the approved mean renounced ownership, and we have name. So which is the name? So it is simple NFT, and the owner is my address, and I'm owner of and a lot of things, right? So we have a lot of information here. So what if I renounce to the ownership? So executed success, simple NFT. So I renounced for this, and the new owner is now no one. No one is the owner of this. So the name is this, and the owner is I don't have. Yeah, so it updated, and now the owner is no one. Okay, cool. I think so. I think so. So like the problem is that we didn't have like the infrastructure. So I think that a real cool example of well infrastructure, community, and like valuable things, if you can imagine, of a good example of kind of metaverse, can be Roblox. Like Roblox is like a really big metaverse. Like everyone can buy their things. Like it's a virtual world. Everyone uses. You don't need to have a really expensive thing to play Roblox. You can play Roblox on your cheapest phone or on your laptop, your computer. You can play Roblox with your friends and so on. I don't need a virtual reality um, thing to keep playing Roblox. So I think that a cool thing for that Roblox makes is that it allows your community to make their own, like you can make your own things. Like you have a market that you can use. You have a kind of currency that are the Roblox, right? And the community is really big. The community is really familiar with you. Um, I think there are not like pretentious things like, hey, yeah, look at my NFT that I bought. That yeah, doesn't do anything, right? But in Roblox, you can buy things that actually give you things like a skin, maybe some kind of pre-rendered world or something like that. So you have a lot of things that you can do with Roblox. So I think that is a good use of metaverse and a good use of currencies. And the currency also has a lot of value. Like, well, let's see how much a Roblox costs. So Roblox Roblox to USD. So blah 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 blah. Blah. Let's keep with Roblox. So for example, here, every Roblox is almost $10. And let me see how many Roblox I need to make just $1. 45 but 100 in this. So like almost 80 Robux are equal to $1. Like see that, like that is a lot. Like that is more than a lot of currencies that are currently used even in the real world. Like yeah, so Roblox has a lot of potential for getting a little bit greater, right? And you can also um, try to use the graphic motor that Roblox has to kind of modify even the graphics so they look a little bit more epic and things like that. So let me just see, for example, uh, Roblox epic. Uh, so see, like you have a lot of things that you can like. This doesn't even look like Roblox. Like you can um, modify like the whole graphic motor of Roblox, however you want to do it. Like in a lot of ways, you can customize your world. You can do tons of things in Roblox, and also I think that is the coolest example of functional metaverse that we have yet. Also, Fortnite is going like from there, like it's almost there. Like Fortnite, it has already updated the graphic model, so you can modify it, make other worlds, use the Unreal Engine 5 to continue playing and building awesome things like um, Unreal 5. So look at this. Like this doesn't even looks like Fortnite. Like you have a lot of things. Like you have a lot of tools to create your own worlds, to create a lot of cool things that you can do. So yeah, like we have a lot. I think the kind of metaverse that the persons try to buy or to build these pyramidal scans is not the same metaverse that we're going to have in the future, right? And I hope that we in the future we have the enough technology to make a little bit cheaper the tools that we need to use, the VR technologies, or that those tools become cheaper, like with better technologies and whatever the world keeps evolutionating. And yeah, but yeah, I think it took a long path with this. Okay, so we saw like this example here in Solidity. um I think we have covered like the principles of Solidity. We have already created our first application. We have already saw the hello world. We already deployed something. We saw variables. Blah, blah, blah. We saw like the data types, name, struct, data functions. We already saw the events. Disability interface called delegated try catch. Okay, try catch I think is an interesting thing that we have not yet solved. Okay, so we have try catch. Try catch can only catch error from external functions, calls, and contract creation. So constant foo is equal to this. So we have to require earning a high valid address and where the you're using the try catch. Okay, here. So try foo my function returns the string memory results. So emit log the results and then the external call fail. So example of try catch with the contract creation. So create a network contract, log invalid address. Okay, yeah. So it is. I think it's the same thing as the ones that we have already built. So import. Okay, so we have already imported. We saw some examples of importing in in the NFT libraries. Blah, 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 blah. So we have import and external. Okay, import. Okay, so you can also import like code from GitHub. Okay, so that is cool. Libraries. So we have library met. Libraries are similar to conduct, but you can. Okay, yeah. So this is really C inspired, creating a library inside of your folder. So we have a library mat. Okay, so we have some functions and that test array, blah blah blah, and also we have ABI encode, function transfer, token, So I want to know what is an ABI code because I never understood it. So what is ABI encode? Okay, so let me share my tab. Okay, so ABI stands for Application Binary Interface. In the context of Ethereum and Solidity, the ABI is critical component for creating with smart contracts both from the also blockchain and between the contracts of blockchain. So when you interact with a smart contract on Ethereum, you don't need to send commands in a traditional sense. Instead, you need to send it a series of bytes. The contract ABI is what allows you to encode a standard JavaScript or other language function calls into those bytes and also the code bytes of data returned from the Ethereum into a readable, easy-readable format. So ABI.encode is a function in Solidity that performs this encoding. Here's a brief overview of the functions available for ABI encoding in Solidity. So ABI encode, this encodes the provided arguments according to the provided types. ABI encode packet, this performs a threaded packing of arguments, which might save on gas, but can be more complex. So also we have ABI encode with selector, but for selector, this encodes the provided arguments along with the given function selector. So ABI that encode with signature, string signature, this encodes the provided arguments, and instead of a selector, you give it a function and signature. Okay, so example, so suppose you have a function in a contract, function set age, so the ABI encoded data for calling this function with an age of 25 may look like a series of bytes, but you generally don't have to worry about this detail when you're using a library or tool like Web3 or EtherJS. So this tool will handle the ABI encoding or decoding for you, and also however you understand the basic, blah, 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 blah. Okay, cool. Cool, cool, cool. So let's continue with this. So we already saw the ABI encode and the ABI decode that I think is the same thing. So encode data into bytes and decode bytes back into data. Okay, cool. So hashing with Kesak 156. Computes the hash into some input, creating a document unique ID from an input, commit reverse scan, combine cryptographic signature. Okay, verifying signature. I think it uses the same thing. So messages can use this, blah blah, smart contract, EtherJS. So how to send a verifying? Okay, so this is interesting, like signing a this contract. Okay, so let's see. So how to sign and verify, sign in, create a message to sign, hash the message, send the sign of chain, keep your private key secret, verify, recreate hash from the original message, recover signer from signatory and hash, compare, record, blah, 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 blah. Okay. So unlock MetaMask account. Okay, so we use the MetaMask account, then get a meta hash to sign. So get meta hash, okay, coffee and donuts. Okay, so sign message has using browser account, copy paste account of signer here, request met her proposing parents account then console log. Oh, coffee with donuts, I want. Oh, I want so bad, like so want like Krispy Kreme donut right now, or a homemade chocolate donut. Like, have you tried like uh, what's called like here in Mexico, we have a coffee called Tim Hortons, and it sells donuts really tasty. Like they are so good. Like I want one of them so bad. Like look at these. Like ah, I want so bad. What? Here's how they look inside the store. Like they look so tasty. Oh, no. No, I want someone. I want one. And also, you have like apple pie, you have like chocolate with almond spice and things like that. Oh, I want one so bad. And all because of this example, coffee and donuts. Okay, so get it. Sign message. Okay, so we use the signature bit by signing hash with the following format. So we have Ethereum sign message, the message, and we use this stack again to encode pack Ethereum sign message into our message hash, and then we verify that signature. So we have the signer, then the amount, the message, and a signature for that. Okay, so is signature a way for verifying that address, or well, it's not that address in this case. I think instead of that, it's like the account or that messenger or yeah, that we know that regardless it was sent from some from some direction, that person, like we want also to verify that that person is the one who is like sending the message or signing a signature to that message, right? Like um, making something like that. I mean, I can imagining. Okay, so when we have function verify, blah blah blah, 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 status, the same thing. Recover signer. So we just send message hash, split signature, and okay. So another thing that I'm real curious of is that what is gas? And because we have also like the gas in Ethereum. So gas is fundamental concept that relates to the execution of transaction and smart contract operation. So at its core, gas serves both a measure of computational work and as a mechanism of incentive or compensate the network validators. Here's a more detailed breakdown. Unit of work. So every operation for simple transactions to complex smart contracts interactions requires computational effort. So gas represents the amount of work needed. Different operations cost different amounts of gas based on their complexity and the amount of resources they consume. So, incentive for miners or validators. So miners in proof of work or validators in proof of stake are responsible for validating and confirming transactions on their Ethereum network. They are compensated for this work through a combination of block rewards and transaction fees. The transaction fees are calculated based on the amount of gas a transaction consumes and the gas price set by the transaction sender. So transactional cost, when you send a transaction, you specify a gas limit and a gas price. So my gas limit is the amount of gas unit you will spend on the transaction for standard ETH transfers. This typically is 21,000 gas. Contract interactions may require more depending on the complexity of the operation. So the gas price is something else. So the amount of Ether you're willing to pay for each unit of gas. So this usually dominating way. So one Ethereum is equal to 1 million. Is it million? No, 1 billion. I think you 1 billion way. So when the network is busy, users might set higher gas prices to prioritize the transactions. Okay, okay, right. Got it. Okay. So out of gas errors, if a transaction consumes more gas than its specified gas limit, it runs out of gas and fails. The operation are reverted, but the gas spent out to that point is not refunded. This system prevents infinite loops or excessive computations, as users must explicitly allocate resources. So then we have refunds. So some operations allow gas refunds, however, these refunds have a limit and do not equate to one-on-one saving on transaction cost. So also we have protection mechanisms. So by acquiring users to pay for computations in the form of gas, Ethereum protects itself from spam and denial of service attacks. It ensures that users only submit transactions they deem worthy of the cost and prevent malicious action from flooding the network with high conventional tasks. It's a measure of computational work and a mechanism for pricing transactions, and a tool is said to be network validators and protecting systems. Okay, cool. So yeah, cool. So I think with this we're almost finished. So let me pass to you the Solidity by example page so you can take a look. Also, if you're coming into the stream first, here's the ID that we are using. It's called remix.ethereum.org, and we are using it for trying for deploying our contracts that we are making. And yeah, so let me know if there's something, if you have any questions, if there's something that you want to know, and if not, I think we're finished with this. I think like we saw like the principles of Solidity. We saw that it's a heavily based C language. We saw some examples of the smart contracts that we can make. Also, we saw some other examples of how to store things in Solidity, how we can interact with the ownership of something. Create a simple ballot, a simple faucet example that will recommended us to do. We also made a hello world and a simple NFT example with the help of ChatGPT. And also we saw how to use the libraries, the import, how to use the function, how what were events, what were how is this called? I forget the name. Let me see. Try catch viable interface blah 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 events instruct function how to use modifiers and things like that. Thank you so much for being here. Thank you so much, Will. Thank you so much, Indigo. And I'll see you there. So have a nice go ahead week, and don't forget to register. Let me pass again the link so you can see it. Forget to register right here. There you go. And this should be all. So thank you so much for being here. My name is David, and it was nice being with you this week. And have a nice global hack week. See ya.